All right, this is Unit 3. We're talking about Newton's laws, but we're on the middle of page 10, and we're starting to transition to talk about the force of friction. The force of friction could be a chapter on its own. We're talking about the frictional drag, or the force of friction, that acts on an object. In physics symbols, this is the force of friction, F sub F. We just read this as the force of friction, and it depends on two things. The first thing is the nature of the surfaces, or the stickiness of the surfaces. So, if you were to feel a rough surface, there's obviously something about it, and if you were to rub your hand across it, something is kind of holding it back, and that's the nature of the surface. It's the stickiness factor. Even if you find a smooth surface, it's not going to be frictionless because there's going to be some sort of interaction on the molecular level. Even something that feels really smooth might have more of a structure like this on the molecular level. So if this were, say, the tile floor, and this were a block of wood, they both feel somewhat smooth. But on this level that we can't see, they're going to be interacting, and it's going to cause some friction. The stickiness of the surface is measured by the coefficient of friction. Second thing is the force of the surface pressing against the moving object. And this is called the normal force. So if a book is sitting on a table, the book is pressing on the table with a force equal to its weight. And the table is pressing on the book with a force equal to the book's weight. So this is some action-reaction forces. On horizontal surfaces, the normal force equals the weight of the object. Note the bold print here. On horizontal surfaces, the normal force equals the weight of the object. To find the frictional drag between two surfaces, we do this experiment. So here is a surface, here is, let's say, the object, and we are going to pull the object at a constant speed. Pulling at a constant speed means no net force. So constant speed, no acceleration, no net force, which means our pull equals force of friction. And we can use some sort of a device to measure how hard we are pulling. So when we pull at a constant speed, our pull equals the force of friction. If we pull just hard enough for the cart to travel in uniform motion, there's no net force. This means that our pull exactly equals the frictional drag. F sub F. Therefore, the scale reading is the force of friction. Our definition for the coefficient of friction this is the Greek letter mu. So let's write this here. Greek letter mu. As a capital letter, it looks like this. as a lowercase letter, we get U with a tail on the front. It's the Greek equivalent of our M. So mu, or the coefficient of friction, equals, and it's two things. First off, the force of friction, and second off, the normal force. So I'm going to write in here F sub F is the frictional drag, and F sub N is the normal force. Remember, on a horizontal surface, the normal force equals the weight of the object. And what about some units? So let's talk about units. What are the units? So if we were looking for mu, my force of friction, the frictional drag, has units of newtons, and my normal force has units of newtons. It has no units. Units, none. So friction example 1, we're looking at the top of page 11. A pull of 500 newtons keeps a 20 kilogram box moving at constant speed. Find the value of the coefficient of friction between the surfaces. So first off, you're always going to want to draw a diagram. So we have a 20 kilogram box, and we are pulling it with a force of 500 newtons. And it's moving at a constant speed, which means there is no net force. No net force. So the force of friction is 500 newtons in the opposite direction. So here's the force of friction. It is 500 newtons in the opposite direction. So remember, on the horizontal surfaces, normal force equals the weight. So mu, or the coefficient of friction, which is the frictional drag divided by the normal force, equals, we figured out the force of friction. It was 500 newtons. And the normal force equals the weight. So remember, weight was equal to mass times gravity. And so the mass is 20 kilograms, and gravity is 10 meters per second squared. So we have 500 newtons divided by 200 newtons, which tells us the coefficient of friction is 2.5. And again, there's no units because newtons cancels with newtons, no units. Example 2, a mass of 80 kilograms is rolled across the floor with a coefficient of friction equal to 0.03. Find the frictional drag between the surfaces. So we have a formula that relates these things, so let's go ahead and write it down. Coefficient of friction equals the force of friction divided by the normal force. But we're looking for the force of friction, and I like to solve the equation before I put numbers in. So the force of friction equals the coefficient of friction times the normal force And we can put in some numbers here. So coefficient of friction is 0.03. Remember, the normal force is equal to the weight, because we're on the floor, that's a horizontal surface. So weight is mass times the acceleration of gravity. Mass times the acceleration of gravity. And so the force of friction in this situation, it comes out to 24 newtons. This is a favorite question. Hint, hint. A push of 30 newtons is required by Joe to keep a piano rolling down the hall at a constant speed. Bill helps Joe push, and the two boys exert a total force of 200 newtons on the 100 kilogram piano. Find the coefficient of friction and find the acceleration of the piano when both boys push. So first, our constant speed diagram. Here's the floor. Here's the piano. This is the situation where we have Joe all by himself. Joe, his force is 80 newtons, and it's at a constant speed, which means no net force. This means the force of friction is 80 newtons. 80 newtons in the opposite direction. Then the diagram for the situation where the piano is accelerating. Here's the surface. Here is the 100 kilogram piano. Joe and Bill together are providing a force of 200 newtons. And then the force of friction is still 80 newtons. So find the coefficient of friction, mu. It is the force of friction over the normal force. We know the force of friction is 80 newtons. And the normal force is the weight of this piano, 100 kilograms, times 10 for the acceleration of gravity. It is 1,000 newtons, which means the coefficient of friction here is 0.08. We want to know the acceleration of this piano as both boys push. So we can use Newton's second law. The acceleration is the net force divided by the mass. The net force in this case, where we have both boys, it is 200 newtons minus the force of friction. So they are exerting 200 newtons in one direction. The piano's friction is exerting 80 newtons against them. 200 newtons minus 80 newtons. And the mass of the piano is 100 kilograms. So we see the net force is actually 120 divided by the mass. And we see that the piano accelerates at 1.2 meters per second squared. Number 4, a pole of 100 newtons accelerates a 5.0 kilogram box at a rate of 6 meters per second squared. Find the coefficient of friction. So first, let's draw a picture here. So here is my horizontal surface. Here is the box. A box is 5 kilograms. We know the pull. It is 100 newtons. We know the acceleration is 6 meters per second squared. So now, the only thing we have to do is solve for the net force. The net force is the mass of the object times acceleration. So the net force, we have 5 kilograms accelerating at 6 meters per second squared. And we see the net force is 30 newtons. Our pull is 100 newtons, and 30 of that is accelerating this object, which means the force of friction is 70 newtons. So find the coefficient of friction. The coefficient of friction is the force of friction divided by the normal force. Force of friction is 70. The normal force is mass times acceleration, is the weight. 5 kilograms times gravity, 50 newtons. And our coefficient of friction, we find it to be 1.4.